insight pada anak-anak bahwa mereka memang harus bersemangat gitu ya to
Yeah,
develop the drug. Okay,
but
I see some question student has already
yeah,
drop their question on the chat box. Yeah, for students, you can ask in bahasa because I think Dr. Hendra also understand in bahasa Indonesia ya, Dok ya.
yeah,
Okay, or in English as well. Okay, I will read the first question from
yeah.
Brigita. Yeah. Okay. Can I ask question? So, or you can directly,
I think I can
you can,
directly read it, Ibu,
oh,
if you
okay,
don't. Yeah.
okay, okay.
I think there is another one from Shakila Nova, ya. Shakila Nova first.
Yeah.
Just above Brigida. Gimana caranya mengubah senyawa obat yang harul menjadi e-karul? Jika diubah menjadi e-karul, apakah masih akan bermasuk? Right. Thank you for the question, Shakila. So, um, what I meant with this, so on slide 75, right? So this is the carol drug, and you see that there is this asymmetric center that can have R or S. So when we say we change carol to a carol, we simply change one of these X, right, or deleting one of these H, so that this carbon is no longer possible to form R or S. Right. So for example, if X is oxygen, right, and then H is hydrogen, Y is nitrogen, I can change X, for example, to another hydrogen. So I can have CH2 groups, so that carbon is no longer going to be carbon. Right? Obviously, if you do that, then you are no longer having that chirality. And obviously, chirality is important because depending on what X is, that can go to in three-dimensional way, that can go and access the actual amino acid residues that you want. And sometimes if you delete that, then you're no longer able to get that interactions. So with your questions, if it's acarol, apakah masih akan berfungsi? It depends on the change that you did. If the change that you are doing is not important for the binding, you'll be fine. But if the change is crucial, then you will see a dramatic drop in the activity. Okay, so I hope that helps. Untuk next one, Miss Brigita, droplet, I want to know how do researchers actually decide when a compound is good enough? Right, so good enough slash not good enough. Lipinski's rule, Pieper's rules, all there is this like specific rules that we try to teach our students at the beginning. But generally, Brigitte, you want it to be reasonably small. When I say small, is less than 1,000 Dalton. So that's a good starting point. You want it that it doesn't have too many hydrogen bonds, donors. So if you have a lot of NH and OHs, that's normally a bad story. You don't want it to be too ionic as well. So if you have, for example, carboxylic acid and amino group at the same time, then chances are you're going to be a sweet ionic compound and you're going to have a hard time with absorption. So it is predictable. So if the question is it predictable or unpredictable, it is predictable. Normally what we do is I have software that I normally use. You basically put in the structure in there and it will tell you very likely this compound is going to be bioavailable or not really. So no, very early on in the lead optimization, we can combine the SAR and the SPR to come up with the best compromise between the two, if you like. Okay, because things that are normally good for the activity, but let's face it, are most of the time not the best for the property effects. So you do need to have a balance between the two. Okay, so I hope that question is answered. Next one, oh, we have quite a few. 15 new messages. Okay, let me try to go a bit faster. Next one, Sophia Vardani. Receptor are classified as a mechanism. How do we determine whether that is suitable? This will we rely on the biologist, Miss Sophia. Okay, the biologist is going to be the one telling us. We suspect that this disease happens because of the abnormalities of receptor X subtype Y, right? And how the question is, how do they know that it is this kind of receptor? Omics. So either the genomics, transcriptomics, proteomic studies, and metabolomics. So typically, we compare, for example, DNA sample from disease patients versus the healthy patients, and we're trying to see some polymorphisms difference between the two. Okay. No, chemists do not have that knowledge. We rely on the biologists. Next one, Harriet, in the context of drug discovery, how do we decide whether to use phenotypic screen or target-based screen? Quite simple, Harriet. If you know the target, you start with a target-based screen because that saves you a lot of time down the line. You have a better control over what you are trying to make in your library. Phenotypic screen, you tend to go sort of blindly, right? Phenotypic screen is more useful when you don't have good hit compound to begin with. Okay, so I think with GPCRs, for example, if you know exactly what GPCRs you are working on, target base is definitely more advantageous. Okay. Next one, Ms. Dewi Praja, what's the primary challenges, especially with technological advancements? The primary challenge, I would say, is what to make, right? What to make and what to cure, and what hasn't been done, and how can we make quick impact by doing things, by identifying those things that haven't been done. So in the past sort of 20 years, people have been looking at repurposing, right? You see it during COVID, people try to use that. It seems like the concept of repurposing, although it's good, but it actually hasn't been very fruitful. And then AlphaFold actually came into mind. And then, as you may be aware as well, there is more and more AI software that can propose to us, hey, this compound could be useful initially for antibacterial, but could be useful, I don't know, for cancer, right? So there is more and more of this AI and machine learning technologies. I think the challenge would be, well, which one do you want to cure first, and how quickly or how adept are you at picking up those connections that people haven't seen before. Okay. Next one, Miss Elsa. Miss Elsa, could rigid molecules increase the risk of immunogenicity due to their unnatural, non-flexible structures? Immunogenicity, probably not. A toxicity, perhaps yes. It could be more toxic because if it's in the natural form, you are seeing that flexibility. So if you like, you don't get as potent of an activity. But when you have rigid molecules, because you improve that potency, perhaps you get hit with some sort of side effects. That is possible. But again, outside the rigid molecules, typically we introduce it to introduce some selectivity. So it will be counterintuitive if we introduce selectivity, but we still get the toxicity. Okay. Next one, Delshad Muhammad. Saya pernah baca pausintesis nanopartikel emas. Apakah benar punya gugus farmakologis untuk pembentuk nanopartikel? I need to see exactly what article you read, Pak Delshad. Yeah. But in general, gold nanoparticles, all these, you need to be very careful with which journals you're reading. Okay. I would generally recommend my students try to read the Q1 and the Q2 journals, and look at the previous publications from that group. Yeah, and sorry, this question is a bit too broad. Without looking at the actual article, I'm afraid I cannot comment. Next one, Miss Sifa, drug target interaction at molecular level. Is it possible for a drug to bind strongly but will still be therapeutically ineffective? It's possible. That is simply meaning that the target that you are trying to optimize the binding for is not the right target for the disease that you are trying to cure. And next one, Imamul Aziz. How can small errors in determining the structure lead to failure of a drug candidate synthesis? The small error in this case tends to be on the physiochemical property side. So, for example, is the compound too lipophilic? Is the compound not water soluble enough? Is the compound having bad pharmacokinetic properties? If the compound is not as metabolically stable? So this tends to be that small error that lead to the failure of the drug candidate synthesis. So that's why these days, not only SAR, but also SPR, the property aspect, needs to be considered early on before we actually invest the money in doing the scale up and doing the clinical trials. Ms. Livia, is it better on new molecules to achieve more beneficial clinical outcomes? Um, it, I think it depends on what the focus of the company or the academic group is. If the focus is on like fundamental new molecules, then obviously it is great. For example, astaxanthin, right, have very powerful antioxidant effects. Obviously, that could be useful for a lot of things, for example, for diabetes. But other new completely molecules, perhaps you're talking about from marine sponges or very unique bacteria, right, in a volcano, that sort of compounds. That's also fundamentally very interesting. So it depends on how much resources you have, is probably the answer I'll give. Fiorella, if a compound violates Lipinski's rule of five, they're not necessarily bad. Okay, that's why I'm saying, although it's a rule, Fiorella, treat it as a guidelines. Okay, you can still save that compound by doing systematic changes, as we just discussed. Kevin, advancement in purification. HPLC now has UHPLC. Spectroscopy technique NMR has like 900 megahertz NMR. So it's quicker, faster, more expensive as well, obviously. X-ray now has cryo EM. So yeah, look, technology will keep up. Question is again, what target do you want to look at first? Right? GPCRs. Oh, that's a nice question by Faradilla. That's right. So there is a bias with the GPCR on the, for example, beta arrestin versus the cyclic AMP. It depends. So with the GPCR, for example, in our cannabimemetics drug discovery, we know that although we have two compounds that has very similar cannabinoid activity, but one, as you said, show more bias towards beta arrestin, for example. So I didn't go through that obviously in the beginning, but this is why when we are looking at GPCR modulators, there often needs to be more follow-up pharmacological assays, right? So emotional blunting, delayed onset, yeah, exactly. So especially for those GPCR modulators for CNS indications, we've seen that with the cannabinoid as well. Great question, Paradila. Isaac, aral ganti posisi, apakah mempengaruhi efek apa aja dalam obat? Mostly the binding. If you're talking orthometapara, that's mostly the binding. And Rom, what's the significance of functional groups? Why might some, in order to maximize binding, after Atayalamarom, you change the functional groups so that your drug binds better to your target. Heavier organic molecules from most medicine. I think I answered that, Livia. Alleele in accordance to drug substance that doesn't fit, can we still alternate? Yes, Alleele, I think I've already answered your question. Similar question was asked previously. Beryl, when you're designing ACE inhibitors, you're adding that hydrophobic pocket. How do you balance this with the potential risk of reduced selectivity or increased toxicity? Um, Again, quite typical. When we do one change, we do need to repeat the rest of the assays barrel. So at least in this case, we know that we get improvement in the ACE. So, but as you said, we do need to repeat the study in another panel of related receptors. Nadia Rahmania, how can
Ya,
we
Dr. Hendra,
yeah,
we are very
ya
kami
udah cukup
sangat
ya.
bergembira ya.
Sorry.
Ya, banyak sekali pertanyaan dari mahasiswa tidak berhenti-berhenti begitu. Akan tetapi sayang sekali waktunya sudah
Iya, iya,
habis.
maaf, maaf.
Ya,
Iya.
dan eh, kami sangat menghargai pertanyaan dari mahasiswa ya. Kalau ada waktu mungkin ya pasti akan dijawab semua gitu ya. Hanya saja
Pasti,
memang
pasti.
waktunya sangat terbatas ya. Sebelumnya beri applause dulu untuk Dr. Hendra ya. Ya, baik. Selanjutnya sebelum kami tutup sesi ini, kami akan menyerahkan sertifikat begitu ya, sertifikat untuk
Pasti.
Dr. Hendra. Ya, boleh di close share
Sebenarnya, ya, maaf. Ya.
ya. Ya. Ya. Berikut adalah sertifikat yang dititipkan oleh dekan kami, Profesor Junaidi Khotib. Ya. Terima kasih banyak Dr. Hendra atas partisipasinya. Bu Yuni mungkin ada yang ingin disampaikan? Sudah? Ya. Baik, terima kasih banyak untuk Bapak Ibu dosen tim teaching juga seluruh peserta mahasiswa kimia dasar ya yang juga kebetulan peserta kimia organik farmasi ya. Untuk saat ini mudah-mudahan setelah mendengarkan perkuliahan ini bisa lebih bersemangat gitu ya untuk